Okay, today we're going to have some fun with quadratic equations and inequalities. We've already discussed quadratic functions. So you have your f of x equals, and then you have that function, that polynomial function with the x squared term and possibly an x term and a constant term. But now we're going to look at the equations and inequalities where you have your ax squared plus bx plus c equals 0. So you're going to be solving for x. Whether it's equals, or it could be also inequalities where it's less than or equal to, greater than, or greater than equal to. So that's what we're doing in this section. So starting out with quadratic equations in one variables. In standard form can be written as ax squared plus bx plus c equals 0. So notice, difference here is it's not equaling f of x or y this time. It's actually equaling 0. And the a, b, and c are real numbers. You got to make sure a is not 0. You got to have that x squared term in there in order for it to be a quadratic equation. If you took out the x squared term and just had the x term, it'd be a linear equation. If you took out both of those, then it would be something that wasn't true because you have some number equals 0. Just, yeah, no, it wouldn't work very well. But you definitely need the x squared term. So there's a few processes you can do to find your solutions, figure out, well, what does x equal to make this a true statement? There's several that we're going to do and then some that we're not going to do. But this process of finding those values that make a true statement for x is not only finding solutions, but also if graphically we're finding zeros or x-intercepts. We're figuring out, if we were to graph the function where instead of equals 0, let's say it equaled f of x or y. If we're graphing that function, where would that function cross the x-axis? What would be the x-intercepts? Well, solving the quadratic equation equal to 0 helps us to find those values. Figuring out where y is 0, what is x? So the three methods we're going to use include the zero product property in factoring, the square root property, and the quadratic formula. There's also a method with completing the square that your book discusses. We're not going to worry about that yet in this section. We'll get into completing the square more later when we talk about circles. So pretty far down the line this semester. So, but don't worry, we'll do completing the square eventually. All right, so we're going to start out with solutions by factoring. You guys have seen this before, especially if you've taken our intermediate algebra class. We're going to take these equations and make sure there's 0 on one side. We're going to factor the non-zero side and work with those factors. This is only going to work if it's factorable. And this works because of the zero product property. If you have two complex numbers that multiply and equal 0, then one or the other has to be 0, or they both could be 0. And we're going to use that principle after we factor to finish solving and figuring out what x equals. Okay, so we're going to put the equation in standard form if it's not already. Make sure we have 0 on one side of the equal sign. Factor the side that's not 0. Set each factor containing the variable equal to 0. And solve those resulting equations. And then we always check by substituting back into the original equation before we started factoring or anything. Okay, and all of this is going to work because of that zero product property and because the equations we're going to work on are factorable. All right, so let's see. Start with the first one. Let's do x squared minus 3x minus 18 equals 0. Okay, so this is a quadratic equation. It is in standard form. You have x squared, which is the same thing as 1x squared. So in this one, your a is 1, minus 3x, so your b is negative 3, and then minus 18, so your c is negative 18. And it equals 0. So standard form. So what we can do is take the side that's not 0, the x squared minus 3x minus 18, and factor that. So x times x will give me x squared. Then for factors of 18, I got to multiply to get minus 18 and add to get minus 3. So 6 and 3 will multiply to give 18 and subtract to give me a 3. I need different signs, and since this is a minus 3, I need the bigger one, 6, to be a minus. And then the smaller one, 3, gets to be a plus. So that'll give me x squared minus 3x minus 18. So that's now that x squared minus 3x minus 18 is factored. And now comes that zero product property. The fact that x minus 6 and x plus 3 multiply and equal 0 tells me that either x minus 6 is 0, so that way you have 0 times something equals 0, or x plus 3 is 0. So that way you have something times 0 equals 0. If two things are multiplying to equal 0, one or the other, or both, have to be 0. So we're going to solve the different cases. We're going to solve the x minus 6 equals 0 case, and we get that x equals 6. We're going to solve the x plus 3 equals 0 case, and get x equals negative 3. So 6 takes care of the case where x minus 6 is 0. Negative 3 takes care of the case where x plus 3 is 0. And that's it. Now we've got our two solutions to this equation. This equation does have two real solutions, negative 3, 6. If we want to check, we can check each solution back into the original equation, and it will work. We can plug negative 3 back in for x squared minus 3x minus 18 equals 0. We get 9 plus 9 minus 18 equals 0. So we get 18 minus 18 is 0. And that's true. We can also plug in 6 into the original equation. X squared minus 3x minus 18 equals 0. So 6 squared is 36. Minus 3 times 6 is 18. 36 minus 18 is 18. And 18 minus 18 is 0. So each one in its own right is a solution to that equation, and that equation has two solutions. So there's an example of solving by factoring. Okay, let me do one more example of solving by factoring. Let's say you have something like, yeah, I want to do one like that. I had ideas in my head of what I want to do. Sometimes I change my mind in the middle of it. Haha. All right. Let's say you have something like x squared plus 25 equals negative 10x. Then you want to solve this by factoring using that zero product property. Well, first of all, this is not in standard form. I don't see a 0 on one side. That's a big red flag going, oh, I got to get this in standard form because I need a 0 on one side. So I'm looking at this, and x squared plus 25 I really can't do a whole lot with. You know, x squared plus 25, there's no simplifying or anything there I can do. But I've got this minus 10x, negative 10x over there on the right, and I need 0 over there on the right. So I'm going to go ahead and add 10x to both sides. And then what that'll do is on the left side allow me to have x squared plus 10x plus 25. And on the right side, negative 10x and plus 10x will give me 0. So I had to put it in standard form first. Okay, now that 0's on one side, now that I've got it in standard form, notice standard form, you know, you're going to have the x squared term, then the x term, then the constant term. Factor. Ooh, I have a perfect square trinomial here, which factors into x plus 5 times x plus 5, or x plus 5 quantity squared. And that equals 0. But since both factors are the same, I don't need to set them both equal to 0 because I'll get the same answer with the two. So I can just worry about one of them. And I could say x plus 5 equals 0, so x equals -5. So -5 is the one and only solution to this one. And if I check, I want to make sure I go back to the original problem. X squared plus 25 equals -10 times -5. So I've got 25 plus 25 on this side, which is 50, equals, well, -10 times -5 is also 50. So it works out. So this particular quadratic equation has one real solution, and that is -5. Okay, so that's one method, factoring using that zero product property. Another method, which only works in specific cases, is the square root property. You have to have a specific form. If you have a quadratic equation where you have something squared equals a number, then you can apply the square root property to try to find your solutions. It doesn't have to just be x squared, but it has to be some quantity squared equals a number. If that number is bigger than 0, so positive, then your solution is going to be plus or minus the square root of that number. If that number is 0, your solution is going to be 0. And if that number's negative, you're going to end up with imaginary solution. So that's where it can get really fun too. Okay, so let's start out with something pretty straightforward. Let's say you have x squared equals 144. If you really want to, you can subtract 144 from both sides, factor, use the factoring property. But you don't have to, because you have something squared equals a number. So you can essentially take your two square roots of both sides. Square root of x squared will give you x, but you've got two possible square roots you can take. So on the right side, you acknowledge that by doing plus or minus the square root of 144. If you have plus the square root of x and plus the square root of 144, the answer is going to be positive. If you had negative on both sides, the answer is going to be positive. If you have plus on one side, negative on the other side, the answer is going to be negative. So you can just say x equals and then just do plus minus over here, and that'll take care of all your possibilities. X equals plus or minus 12. So you do have two solutions here, -12 and +12. Two solutions. And as you check, we'll check -12 first. -12 times -12 is 144. So that works. Woohoo. And if you check +12, well, +12 times +12 is also 144. So that works too. All right, let's see here. Let's try another one. Let's say you have something like 2x minus 5 quantity squared equals 0. Well, that's cool. All right, you have something squared equals a number. In this case, your k is 0. Now, notice earlier, your k was positive with 144. You ended up with two real solutions, plus or minus the square root, two reals. Now your k is 0. So you're going to have 2x minus 5 equals plus or minus square root of 0. But heck, square root of 0 is 0, and 0 you don't have to do plus or minus. It's its own thing. So 2x minus 5 equals 0. But notice that you're not done yet. Because you don't have x equals, you have 2x minus 5 equals, because you did the square root of 2x minus 5 squared. So you got to finish solving for x. 2x equals 5, x equals 5 halves. So in this particular situation, your k was 0, you ended up with one real solution. You can go back and check by plugging into the original equation. 2 times 5/2 is 5. 5 minus 5 is 0, and 0 squared is indeed 0. So that works out. So k is positive, you end up with 2 reals. K is 0, you end up with 1 real. And then if k is negative, we talked about that briefly in that one slide, then you get that lovely imaginary stuff. All right, let's say you have something like this. Negative 2x plus 5 squared equals negative 8. Okay, so you have a quantity squared equals a number. You can go ahead and use your square root property. Plus or minus square root of both sides. So negative 2x plus 5 equals plus or minus square root of negative 8. Well, now you're taking the square root of a negative. So that introduces I. So we got plus or minus I square roots of 8. And then 8 factors into 4 times 2. So I can simplify that further. Square root of 4 is 2. And then I have that other 2 still left over on the inside. So I've got plus or minus 2i square roots of 2 over there. But I'm not done, because I'm not finished solving for x. So I do have to subtract 5 from both sides. And then I do have to divide by negative 2 on both sides. Now at this point, you're more than welcome to leave the answer as is. There's nothing wrong with it. But if you're dealing with a multiple choice kind of format, might notice that your answers don't always look the same as how you got it. So they might need you to go a little further and break this up. If you have a plus or minus up here in the numerator of a fraction, you can break this up into separate fractions. You can put the negative 5 over the negative 2, plus or minus the 2i square roots of 2 over the negative 2. Well, negative 5 over negative 2 is positive 5/2, plus or minus. And then 2 over negative 2 is negative 1, but over here you got plus minus. Plus turns to minus, minus turns to plus, you still have plus minus. So you can just say 1 or I square roots of 2 right there. So there's your 2 solutions. And you can check it if you want, but I'm not going to require it when it comes to i's. When you have the non-real, when you have the complex numbers with I in them, you can check them. You can plug each of those in to the original equation and you'll see that it does work, but I'm not going to worry about checking for those. All right, and here's the one that probably everybody's familiar with, quadratic formula. If you want to see how the quadratic formula is derived, where we get that crazy big formula, check out your current textbook. Right now we're using the Graphical Approach to Algebra, Hornsby, Lyle, Roxwold. And on page 192 of that textbook, they go through and show you how to use completing the square to derive the quadratic formula. I'm just going to throw the formula at you and start using it. It's nice because it'll work for any of your quadratic equations. If you have imaginary solutions or if you have 1 real, 2 real, it doesn't really matter. So if you have a quadratic equation, ax squared plus bx plus c equals 0, of course where a is not 0, quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So plugging in your a, b, and c values, those numbers, those coefficients, and then simplifying from this formula will help you to see what x equals. It'll help you to solve for x. If you're looking at that formula and feeling a little overwhelmed, there's quite a few tools to help you to try to memorize it. One tool, some people like to sing, and a common little song is something like to the tune of like row, row, row your boat, or some other kid song. You can say like x equals negative b plus or minus square root b squared minus 4ac all over 2a. Something like that, Sing it. Now to go in and take your test, don't sing it out loud, but you'll sing it in your head. That might help. That's one way to do it. Hopefully I didn't just scar you with my singing, but anyways. Or you can go online and do some research on YouTube. There's a couple of great videos that you might enjoy watching. There's one, if you do a search on YouTube for quadratic formula and Emily, there's this little girl named Emily she's like 2 or 3 years old, and she sings the formula. It's so cute. That might help you remember. And then there's 2 teachers who used Adele's Rolling in the Deep, and they wrote their own version about the quadratic formula, and they do a good job. So that might be something to check out. Or you can think about your story. There's that little story. I'm not always clear on how it goes, but it's something about there was once a boy who was feeling negative, and he couldn't decide. So the plus minus, he couldn't decide whether he wanted to go to a radical party. So he didn't want to be square. So he took out 4 awesome chicks, and they all stayed out over 2 a.m. And as you tell that story, you kind of work your way through the formula. There was a boy who was feeling down, kind of negative, so that's the negative b. He couldn't decide, that's the plus minus, whether he wanted to go to a radical party. That's your square root sign. But he didn't want to be square, so there's your b squared. So he took out 4 awesome chicks. That's your minus 4ac. And they all stayed out until after 2 a.m. So over 2a. So little stories or songs, those kinds of things might help. Okay, so let's take that formula and let's use it to solve a couple of equations so that you can see how it's done. And that's really the best way to remember the equation. Just keep using it over and over again, and eventually it's going to stick. All right, let's see here. Let's start with x plus 2 times x minus 1 equals 7x plus 5. Okay, now to get this equation to work for you, you do have to have, in order to get the formula to work for you, you do have to have the equation in standard form. And at first glance, it's tempting to think that this is already factored here and here, but we can't use those factors because of the 7x plus 5 on the right. So what we got to do is go ahead and multiply those together. Go ahead and use our distributive property. Multiply everything together. So you're going to have x squared minus 1x plus 2x minus 2 equals 7x plus 5. So x squared plus x minus 2 equals 7x plus 5. Subtract 7x from both sides. Subtract 5 from both sides. And there you go. Now technically you do have a problem here that you could use factoring to solve, but our point today is to use the quadratic formula. A is 1, B is negative 6, C is negative 7. X equals negative B plus or minus square root B squared minus 4AC all over 2a. So negative b is the formula, but our value for b is also negative. So you have negative negative 6 or positive 6 plus or minus square root 36 plus 28. That's all over 2. So x equals 6 plus or minus square root of 64 all over 2. So x equals 6 plus or minus 8 all over 2. So you have 6 plus 8 over 2, which is 14 over 2, or 7. And you have 6 minus 8 over 2, negative 2 over 2, which is negative 1. So you have two solutions, two real solutions, negative 1 and 7, which you could have gotten those by factoring, but I wanted to show you how to use the quadratic formula to get them. Okay, so that's two real solutions. Let's do one where you're going to end up with two imaginary solutions. Let's do one of those. X squared equals negative 3 minus 3x. Need it in standard form first. X squared plus 3x plus 3 equals 0. This is not factorable, by the way. Your a is 1, your b is 3, your c is 3. You're going to notice that as I plug into the quadratic formula, I like to put parentheses around the values I'm plugging in. Negative b plus or minus square root b squared minus 4ac all over 2 times a. So we've got negative 3 plus or minus square root 9 minus 12 all over 2. So x equals negative 3 plus or minus square root of negative 3 all over 2. So you can just say, x equals negative 3 plus or minus I square roots of 3 all over 2. Or if you want to break it up into separate fractions, x equals negative 3 halves plus or minus. And then a couple little different ways you could say this. You could say square root of 3 over 2i. That's one way to write that. But you got a little bit of flexibility there with how you could write it, and what form you put, can depend on like whether you're doing multiple choice or something. So there you go. So there's your example with two imaginary solutions. So either one of these could be said to be your two solutions. Your plus is one solution, your minus is the other. The b squared minus 4ac part of the formula is called the discriminant. Examining the result of this expression can reveal the number and type of solutions to the quadratic equation. If your discriminant is positive, you've got two real solutions. If it's 0, you have one real solution. If it's negative, you have two imaginary solutions. Let's go back here. Let's first look at this one. Change my ink color. My discriminant here was 64. Notice that 64 is positive, so then I ended up with two real solutions. I have my discriminant is greater than 0. And then in this one, my discriminant was negative, and notice I ended up with two imaginary solutions. So that discriminant can tell you a lot about what to expect in your problem. Okay, and the one I did not do was a discriminant of 0. So let me do one of those real quickly here. Change my ink color back to black so we can do a new problem. Let's do one where your discriminant is 0, and then you'll see the one real solution that comes about with that. Let's say you have something like 4x squared plus 12x plus 9 equals 0. Okay. A is 4, B is 12, C is 9. Some of you might already notice that 4x squared plus 12x plus 9 is actually a 4x squared trinomial. So kind of a little pattern there. All right, x equals negative b plus or minus square root b squared minus 4ac all over 2 times a. So x equals negative 12 plus or minus square root 144 minus 4 times 4 is 16. 16 times 9 is also 144 all over 8. So x equals negative 12 plus or minus square root is 0 all over 8. So there you go where you have discriminant of 0. So x equals negative 12 over 8 or negative 3/2. So here, discriminant is 0. And then notice we have one real solution in that case. So that b squared minus 4ac part of the formula can tell you how many solutions and what types. And even more exciting, it can tell you a little bit about the graphs of the related functions. When you put your equation in to your calculator and graph it, you're going to find that the zeros of the functions do match up with those solutions from solving the equations when they're equal to 0. And you've got certain patterns that occur. If your graph intersects the x-axis twice, that goes along with having 2 real solutions. If your graph intersects the x-axis once, that goes along with having 1 real solution. Does not intersect the x-axis, you got 2 imaginary solutions. So let's go back first to this one. And we need to take the standard form and put that into the calculator. So we're going to take x squared minus 6x minus 7 and put that in. And then we're going to hit graph. Okay, I'm going to zoom out. So number 3. And then you can see that it's a parabola. And you can see that it intersects the x-axis in 2 places. All right, so I'm going to zoom back in just so I can better compute where it intersects the x-axis. All right, I'm going to go to second calc. And those points of intersection are your zeros of the function. So we're going to use number 2 there, 0. I'm going to find this one on the left, so I'm going to make sure the cursor is to the left of that 0. Hit enter. Then I'm going to make sure the cursor is to the right of that 0. Hit enter. Enter again. And it tells me x equals negative 1, y equals 0. So that point, negative 1 comma 0, is a 0 of the function. It's where the graph crosses the x-axis. But x equals negative 1 is also a solution to the quadratic equation x squared minus 6x minus 7 equals 0. Let's calculate the other one. So number 2 again. Let's go over here. Calculate the one on the right. There's my cursor. All right, enter, enter, and then enter to guess. And it says x equals 7, y equals 0. So that point is 7 comma 0. Totally expected, because my 2 real solutions were negative 1 and 7. Okay, then this one, 4x squared plus 12x plus 9. Let's put that one in. Graph. This one only touches the x-axis in one place, and that's at the vertex. When we solved it, remember, we only got one real solution. Oops. Let's do this. When we solved it, we only got one real solution. Our discriminant was 0. We got -3/2 for our one real solution. So that doesn't surprise me. So this vertex should be at x equals -3/2. So let's go ahead and calculate 0. Make sure we're to the left first. Hit enter. And make sure we're to the right. Hit enter. And enter again. And x equals -1.5, 0. -3/2. Exactly what I expected. Because when I solved the equation, I got -3/2 for my solution. Okay, and then this one. X squared plus 3x plus 3 equals 0. All right, graph. Let's zoom in a little. Notice this graph here does not touch the x-axis. The vertex is here above the x-axis. It never crosses the x-axis. So this is an example of one where you have two imaginary solutions. Two imaginary solutions, your graph's either going to be above or below the x-axis. It's never going to touch it. So that's a key example there. All right. So there's all your graph possibilities. Intersects the x-axis twice was 2 reals. X-axis once was 1 real. That's where your vertex is sitting on the x-axis. Does not intersect the x-axis, 2 imaginaries. Okay, so there's your quadratic equations. Plenty of fun with those. The other thing in this section that they want you to handle is quadratic inequalities. If you can handle quadratic equations, handling inequalities is not much of a step more. Inequality, you're dealing with less thans and greater thans. So you're going to be looking at where's the graph above the x-axis, where is it below the x-axis? If your equation's greater than 0, you're talking positives above the x-axis. If your equation's less than 0, you're talking negatives below the x-axis. So you're going to go ahead and solve the problem like it's an equation and see where the graph would cross the x-axis. And you're going to use that to come up with 3 intervals. Or come up with some intervals. Might be 2 intervals, might be 3. Just depends on the situation. You'll pick a point from each interval and plug it into the problem and see whether you get a positive or negative result. Any positive results give you the intervals to satisfy greater than 0. Any negative results give you the intervals to satisfy less than 0. And you got to pick which intervals go with the problem you're working on. Okay, for example, let's say you have a question like x squared plus 6x plus 8 is less than 0. Okay, so this looks a lot like your quadratic equations you've been solving, except for this less than sign. So what you are going to do is you're going to first find where x squared plus 6x plus 8 equals 0. Okay, this one's factorable. So I can say, well, x plus 2 times x plus 4 equals 0. X plus 2 equals 0, so x equals -2, or x plus 4 is 0, So x equals -4. Okay, so on a graph, we know that the graph's going to cross the x-axis here and here. We also know that a equals 1, so a is positive, so that means our graph's going to hold water. It's going to be cupped. So we're going to have a parabola that looks something like this. Okay, and I can actually see right away where my solution is going to be. The question says less than 0. Less than 0, you're looking at where does it dip below the x-axis. Because below the x-axis, down here, you got negative. Up here above the x-axis, you got positive. So from -4 to -2, it's below the x-axis. Right here. And since it's just less than, not less than or equal to, you don't want to include the -4 and -2. -4 and -2 are where it equals 0. Now, analytically, let's say you don't have the graph and you want to figure this out. Analytically, you can make a little sign chart. You can do a chart where you first set up intervals. You have intervals going from -infinity to your -4. Then you have one from -4 to your -2. Then from your -2 to positive infinity. You go through and you pick points in your intervals. These are test points. So you might pick -5 in this one, you might pick -3 in this one, you might pick 0 in this one. And you figure out what your signs will be if you plug those test points into x² + 6x + 8. Well, if you plug it into that one, you're going to have a positive result. You plug -3 into x² + 6x + 8, you're going to have a negative result. And if you plug 0 in, you're going to have a positive result. And we're looking for the negatives. So we're looking at -4, -2, because negative is below the x-axis. Less than 0. So there's your solution. So your solution for this particular inequality is an interval. -4 and -2 are the two solutions for them to equal 0, but the interval from the open interval from -4 to -2 includes all these values in between. And for all those x values in between, you can plug those into x² + 6x + 8, and you're always going to get a negative or less than 0 result. All right, let's do another one. Let's try 2x² - 9x is greater than or equal to -4. So we got 2x² - 9x + 4 is greater than or equal to 0. So we gotta get it in that standard form. We get 0 on one side. And let's see, let's find out where it equals 0. So can we factor this? Yes, it is factorable. We've got 2x minus 1 equals 0. So 2x equals 1, x equals 1/2. We got x minus 4 equals 0, x equals 4. So two solutions for the equals 0 part. Then we could do intervals from -infinity to the 1/2, from the 1/2 to the 4, and from 4 to infinity. So it's intervals of the domain. I'm going to pick 0, 1, and 5 out of those intervals. If I plug in 0, I'm going to get something positive. If I plug in 1, something negative. If I plug in 5, something positive. And I want greater than or equal to 0. So positive is greater than 0. Positive is greater than 0. So I'm looking at -infinity to 1/2, and I'm looking at 4 to infinity. But notice the original problem says greater than or equal to 0. So I need to go ahead and include the 1/2 and the 4. So I need to put brackets on the 1/2 and the 4 to make sure I include those as part of the solution. So 1/2 and 4 will take care of that equals to part. And then everything below 1/2 and everything above 4 will take care of that greater than part. And if you were to graph this particular problem, let's see. One half's right here. 4's right here. And you want greater than, oh, sorry. Yeah, never mind. I said oops, no, I wasn't fine. You want greater than 0, that's over here and over here. This part down here is less than 0. It's down, it's on the y-axis, that's negative. It's below the x-axis. Down here is negative or less than 0. Up there is positive or greater than 0. But you want your solutions to be written using your x values. So you say from -infinity to 1/2 union 4 to infinity. And then you use the brackets to include because of the equals to sign. So there you go. So for less than or less than equal to, see where the graph falls below the x-axis, use those intervals of the domain. For greater than or greater than equal to 0, see where the graph falls above the x-axis and use those intervals of the domain. Be careful when deciding whether or not to include endpoints. Remember, less than or greater than, use parentheses. And less than equal to or greater than equal to, use brackets. Just to remind you. Okay, so you got plenty of problems and fun with that. So you want to make sure you're solid on solving these equations and inequalities, because next up will be application problems. Fancy way of saying word problems. Word. So then, yeah, you're going to be setting up equations and inequalities and trying to use those to solve some word problems. So practice, practice, and see you next time.